Okay, this video is about section 7.1, where we're going to kind of look at some vocabulary and get you a little bit more familiar with the difference between statistics and parameters. So, if a problem is ever referring to a statistic, that means that it's talking about something that comes from a sample. So it could be a sample mean, it could be a sample proportion, or a sample standard deviation. And it's kind of nice because the word statistic starts with an S and the word sample starts with an S. So that might help you remember statistic is something dealing with a sample. So if you're talking about a sample mean, you got to use X bar. If you're talking about a sample proportion, you got to use P hat. Sample standard deviation, you got to use an S. If a problem is talking about a parameter, parameter starts with a P, so does population. So anything that's talking about a parameter is something to do with the entire population. So that might be a population mean. If that's the case, you're going to use mu. Population proportion is just P. So I hope you see that difference between P and P hat. They're not interchangeable, they are different things. So if you need the hat, you better put it on. Let's see, population standard deviation, that's our little sigma. When we've done z-scores, we've needed to know the population mean and the population standard deviation. Problem is, in real life, we don't always know those two things. That's kind of the whole point of sampling. We take a sample or several samples. We take samples to try to estimate the population. And it might be we're trying to estimate the population mean, or we might be trying to estimate the population proportion. So that's where we're headed in the later chapters, probably starting chapter 8. This idea that we'll probably no longer know those values. So that means that we're probably not going to be able to use z-scores. But what we're going to do eventually is use a modified z-score, which is called a t-score, kind of, a t-test statistic. But anyway, I'm kind of jumping ahead. Bottom line is, you got to get your symbols correct. Symbols matter. So don't think, oh, it's no big deal if I leave the hat off. It is a big deal. You're conveying different information. We've talked about this before, but like the mean ACT score at BSM is what? I can't remember now. Is it like 25 or something? Let's just pretend it's 25. Maybe it's higher. I don't remember. The mean ACT score for the nation, what is that? More like 21? But in any case, it's the symbols that convey that. So if BSM is just a sample of the entire nation, then our sample mean would be X bar. And the whole nation's mean would be the population. And that would be mu. Okay, so symbols matter. All right, next page. So I actually jumped ahead of myself, and I already kind of said this, but it's okay to say it again. In real life, after chapter 7, we don't usually know mu and sigma. That's what we are going to try to be predicting or estimating. But in this chapter, we're going to be given those values just so that we can understand the general concepts. Moving forward, we won't know them. So in red is what I've been saying. Our ultimate goal is to estimate parameters based on statistics. So we're estimating stuff about the population. Estimating stuff about the population based on samples. So remember, population P, that goes with the P in parameter. S for sample goes with the S for statistics. So if we were to take lots and lots and lots of samples, we are trying to get X bar to be as close to mu as possible, if that's what we're trying to estimate. And we would want P hat to be as close as P as possible. So remember, this is the true population proportion. Or this would be the true population mean. So like dealing with our pennies, if we took a sample of pennies, we would want our sample average year to be as close to the true average year. And the true average year was, hang on, let me just write it down. So the true average for the years was like 2001.4, I want to say. So we would want our sample mean to be as close to that as possible. Okay. Next page. All right, we did talk about this in class, but it's just kind of nice to have it written out. So, a sampling distribution. Sampling. Don't say sample distribution. Because if you say sample, that implies only one. And that is not the case, because with a sampling distribution, it is all possible samples of the same size from the same population. So with the pennies, it was like all possible groups of 3 pennies out of the total in the bag, which was like 250. So trying to pick every single possible combination of 3 would take a very long time, but that is what a sampling distribution is. Sampling variability is just talking about the idea of every time you take a sample, your results are going to vary. And that's exactly what this says. Sampling variability refers to how much our results vary from sample to sample and is measured using the spread of the random sample. So remember in our graphs, the n equals 3 graph was kind of more like this, versus the n equals 12 graph looked maybe a little bit more like this. So this has more variability. Because it's more spread out. This graph had less variability. Okay, and that whole idea of variability is based primarily on the size of the random sample. So if you take a larger sample size, what will the variability be, more or less? A larger sample size has less variability. A smaller sample size like here, a smaller sample size is going to have more variability. The spread does, right here in red, the spread does not depend on the size of the population. It depends on the size of the sample. There's a little bit of a catch as long as it is at least 10 times larger than the sample. So as long as the population, I'll write it over here, as long as the population is more than 10 times your sample size. We'll get into that more later, but it's a little bit of a catch. It'll be a condition we'll have to check in order to do some things later. Okay, the last kind of concept is talking about bias versus unbiased. And in stats, I think we've mentioned this before, that the word bias means something a little different than your everyday language. So unbiased, a statistic is unbiased if the distribution of samples is centered around the true population parameter. And again, parameter is dealing with population. So we're talking about a population mean or proportion. So, okay, if we were talking about our pennies graph, and let's say our dot plots had turned out to look kind of like that, but let's say that this right here was the true average year. So let's pretend that that was the year 2001. Do you see how the center, here's the distribution, the center of that distribution does not match what the true population mean was? So this would be biased. Unbiased would mean, okay, here's your distribution of pennies, and this is the center, which just so happens to be pretty much right on target with the true population mean. So this would be unbiased. So in other words, if it's biased, it's going to consistently overestimate or underestimate the parameter. So like in this case, this is overestimating. Because this would be a year bigger than 2001, so we would be overestimating the true population mean. So basically, it's how on target are you? So with that, I've got a quick little example with darts. And I kind of mentioned this in class the other day. So we're going to compare both bias and variability. So bias is how on target are you, and variability is how spread out are you. Okay, so in example A, we've got a whole bunch of dots that are off target, because here's the bullseye. They are away from the target. So that means that this is biased. I'm going to say it has high bias. And then as far as variability goes, are they spread out or are they pretty close together? Compared to these other graphs, I would say they're pretty spread out. So that would mean it has high variability. In B, they are right on target. That's a good thing. So that means we have low bias. And then they're all clustered together, which means we have low variability. So those are both good things. Low bias, low variability. In C, they're off target, so we have high bias, but they're clumped together, so they have low variability. And then the last one, D, they're scattered around the target. They're relatively close to the target. So I would say that that would be low bias. But they're all spread out, so that would be high variability. So that's kind of an example of all those different combinations. We want to be consistent, and we want to be precise. So this bias would be about being precise, and variability would be about being consistent. Okay, so I think what's coming up next is an example of kind of putting all that terminology together. And we're almost done. So we have a Gallup poll that asked a random sample of 515 U.S. adults whether or not they believe in ghosts. Of the respondents, 160 said yes. So we have to identify the population, the parameter of interest, sample, and the sample statistic. So what constitutes the population? Who or what make up the population? And Gallup poll is a United States poll, so the population is United States adults. Okay. Who were the sample? I'm going to skip down here to sample. The sample was 515 U.S. adults. And maybe up here for population, we could have said all United States adults, and the sample is just the 515 that were polled. Now, what is the parameter of interest? What are we trying to figure out? So we're trying to figure out a mean or a proportion. If we went back to when we defined parameter, scroll. Okay, parameter. A parameter could be a mean, it could be a proportion, or it could be a standard deviation. So in this particular problem, what are we gonna conclude? If we're talking about whether or not you believe in ghosts, and that many people said yes. Okay, 160 out of the 515 said yes. So that is a proportion. So the parameter of interest would be the proportion of all U.S. adults who believe in ghosts. Now, that is an unknown thing. We don't know what the proportion is for all United States adults. All we know here is what we got in our sample. Our sample statistic was a proportion. It was the 160 out of 515. But we need the correct symbol. So what symbol do we use for a sample proportion? We would use p hat. So we know p hat, the parameter of interest, the proportion of all U.S. adults who believe in ghosts, that would be p. So we know p hat, we're trying to estimate p. Okay, so you're going to have some problems in the homework that look just like that. Identify who's in the sample, who's in the whole population, what's the parameter of interest, like what are we trying to figure out, and then what is our data showing us in our sample. And then use the correct symbols. And lastly, one last problem. You're going to have homework problems just like this. So Florida has played a key role in recent presidential elections. Voter registration records show that 41% of Florida voters are registered as Democrats. To test a random digit dialing device, you use it to call 250 randomly chosen residential telephones in Florida. Of the registered voters contacted, 33% are registered Democrats. So for each highlighted value, so this value right here and this value right here, we have to figure out which one is a parameter and which one is a statistic. So remember, a parameter comes from the population and a statistic comes from a sample. So this 41% right here, is that a sample or a population? And if you reread it, it says, voter registration records show that 41% of Florida voters, so that would imply all Florida voters, are Democrats. 41% of all the Florida voters are Democrats. So that is a population thing, so that is your parameter. And then the 33% were only of the registered voters that were contacted. So they called up people, 33% of those they were able to get a hold of, which would be the sample, were registered Democrats. So that 33% is the statistic. And then use the appropriate notation to describe each number. So these are proportions. So our parameter would be our population proportion, which is P. So that would be the 41%. And our statistic would be our sample proportion, which is P hat. And the sample proportion was 33%. So being able to identify which is which and then use the correct symbols. Okay, so your homework is a worksheet that's basically very much like these notes. All right, and I can come around and help you. You should have plenty of time to get the worksheet done. All right, have a good one.